It's another Monday here with teacher Jenny. Join me for another topic, and this time we're going to talk about limits at infinity, wherein this has been an activity given, or this is an additional practice. Let's go for the first one. We have the limit of 3 over x plus 1 as your x approaches positive infinity. Now, for the long method here, you can actually do it like since on the denominator, you've got there an x with a degree of 1. So all you have to do is to simply multiply the entire thing with 1 over x. And so with the top with 1 over x. And then let's simplify this. This is now the limit of 3 times 1 over x. This is similar with 3 over 1. So 3 times 1, that will be a 3. 1 times x, that's an x, over x plus 1 times 1 over x. This is similar to when you have x times 1 over x plus 1 times 1 over x. So we're just distributing 1 over x to our terms x plus 1 as your x approaches positive infinity. So simplifying our lower part, this will be now the limit of 3 over x all over x times 1 over x. This is similar to x over 1 times 1 over x. So we'll do x times 1, that's an x. 1 times x, that's an x. And then plus 1 times 1 over x. Any number multiplied to 1 is still the number. So that means to say that 1 times 1 over x, that is simply 1 over x, as your x approaches positive infinity. Now, based on this one, we can simplify this further. So this will be now limit of 3 over x all over x is 1 plus 1 over x as your x approaches positive infinity. Now, out from here, we can simply put the limit at the top or the numerator and then put the limit at the bottom part. So this is now the limit of 3 over x as your x approaches positive infinity over the limit of 1 plus 1 over x as your x approaches positive infinity. So based on that one, we can now use our theorem wherein we can have our 3 out. And then we have the limit of 1 over x. Once you try to extract your 3, because 3 is the common multiple for that one, so we can take it out from the limit expression. And then we still have 1 over x in there. And then that will be over the limit. We will be using now the limit laws for addition. So we have the limit of 1 as your x approaches positive infinity plus the limit of 1 over x as your x approaches positive infinity. So we are now to simplify. We've got 3 times limit of 1 over x as your x approaches to positive infinity. This is equivalent to a 0 over the limit of 1 as x approaches positive infinity. This is the limit of a constant that is equivalent to the constant. And then plus limit of 1 over x as your x approaches positive infinity. This is a 0. So simplifying, this is now 3 times 0 is 0 over 1 plus 0, that's 1. Simplifying that 1 over 0 or 0 over n, that's on. That means to say this is equivalent to a 0. So this is 0. So that is now the limit of that expression. The next one is a limit of 3 plus 5y squared over 1 minus 2y squared as your y approaches negative infinity. Now, based on the previous videos, the videos on part 3 and 4, I think you can go over with that one. There's a shortcut for this because if you are going to use the long method, it will take time. So you can take the shortcut wherein we are utilizing the concept for the horizontal asymptote. So the horizontal asymptote here, in which we are merely getting our terms that contains the highest degree or the highest exponent, and the highest exponent variable in there. So for the denominator, we have this as the entire term that contains the highest exponent variable. And at the top, at the numerator, we are going to get the highest exponent variable as well, get the term. So this one is the highest exponent variable. And then we are to compare their exponents. Now, giving the recap, once we have our expression like this, x to the power of n over x to the power of m, in which once we are going to consider n as greater than our m. So we need to say our exponent at the top is bigger than m. This would lead to either, when we're talking about horizontal asymptote, this is horizontal asymptote that does not exist. But for the limit, we are going to take it as either possibilities here. It's going to be either positive infinity or negative infinity. Now, if your exponent at the top is equal to the exponent at the bottom part, we are just simply going to get our coefficients of our variables. So let's say this is our a, this is b. Given that our exponents are the same, then we will have our a over b as our limit. Now, if your n is less than m, that means to say that the exponent at the bottom part is bigger as compared to the exponent at the top, then we are going to consider that the limit is a 0. So we'll be using that one. Now, notice that here we've got 2. At the bottom part, we've got 2. We have the same exponent, so our n is equal to m. That means to say we are going to take our coefficient or the numbers beside the variable with the square as an exponent. So we have here at the top, we've got positive 5, so this will be a 5, over, we've got a negative 2 beside your y squared. That's gonna be with over a negative 2. Positive divided by negative, that will give off a negative result. So we have negative 5 over 2 is our limit of that one. Next up, we have the limit of 5r cubed plus 2r squared minus 4r over r squared minus 7 as your r approaches negative infinity. So at the top, we've got the highest exponent variable here. The term is this one. While at the bottom part, the highest exponent variable here is this one. Comparing the two, our exponent at the top is bigger than our exponent at the bottom part. So if this is the case, we are going to get the limit of, get those terms. We have 5r cubed over r squared as your r approaches negative infinity. Why are we getting this? Because we will be simplifying this one, and if there is still a variable, we'll be replacing the variable there with the approach value. So this is now our limit. Simplifying this, we have 5, and then r cubed r cubed divided by r squared. We are simply having our exponent here subtracted because they have the same variable. So 3 minus 2 as your r approaches negative infinity. So simplifying that, we've got limit of 5 r to the power of 3 minus 2, that's 1, as your r approaches negative infinity, and then we replace r with negative infinity. So this is now 5, and then r will be negative infinity. Then this will be equal to positive 5 times negative infinity. That is still a negative number. So we've got a negative infinity as the limit of this. Next, we have the limit of s over square root of s squared minus 7 as your s approaches positive infinity. Now this time, this is a different scenario because we've got radical symbol on our denominator. So what we are going to do here is to again focus on the denominator and check what is there. So there we've got an s squared inside the radical symbol. So this is what we're going to do. Since that is inside the radical symbol, we are going to multiply that with the radical symbol. And inside the radical symbol is gonna be 1 over your variable and the highest exponent here. The variable with the highest exponent is this one. So we've got that as s squared. Now, at the top, because we don't have our radical symbol at the top. So what we are going to do is we are going to simplify this, the one at the bottom part. Simplifying that one doesn't change the meaning at all. So we just have to do the simplest form for that, wherein we can simplify that as square root of 1 over square root of s squared. That is under the law of radicals, wherein once you've got a radical symbol with a fraction inside, you can actually separate, get the radical, get the value, the corresponding radical value of the numerator, and so with the denominator. So this will be now equal to square root of 1 is 1 over, this can be canceled, so we have an s. So meaning to say, your square root of 1 over s squared is equivalent to 1 over s. So at the top, we will not be using square root of 1 over s squared, but the equivalent expression of that one, which is 1 over s. The reason here is we cannot simplify the top when we use the square root of 1 over s squared, because the rule in multiplying radical expression, it must be that they have the same index. In that manner, index meaning to say the number in here, even though we don't have a number visible here, this is understood with 2, and so with this one. So if they have the same index, we can simply let this one in this radical symbol, inside the radical symbol here. So meaning to say we can now multiply. But if you don't have the radical symbol, we cannot actually let that in the radical. Okay, so to give you an idea as to what I'm talking here, so let's now simplify this. Limit of your s times 1s, this is understood with 1 here. So this will be s over s. Over, we've got here the square root of. So since they have the same index, all we have to do is to have the s squared minus 7, multiply that with 1 over s squared. So see, your 1 over s squared is now inside the radical symbol because they have the same index. Okay, that is the rule in multiplying radical expressions. So next one, we are to simplify. So this one is the limit of 1 over, and then we have here square root of, we are going to simplify the bottom part. So we have s squared times 1 over s squared. So we are now simply distributing our 1 over s squared. And then we have minus 7 times 1 over s squared. So if you can do it quickly, then that's better. If you can just simply spot that you are going to simply multiply that one with 1 over s squared, then that's good. I mean, what I meant is you can multiply the entire radicand, meaning the expressions inside the radical symbol, then be it. That's really fine. Okay, next one, we are going to simplify the bottom part still. So we can simply start off distributing the limit at the top, so we can have the limit of 1 as your s approaches positive infinity. At the bottom part, we've got also the limit of square root of s squared times 1 over s squared. This is understood with 1 here. So s squared times 1, that's s squared, over 1 times s squared, that is s squared. And then we have minus 7 is with 1 here, so 7 times 1, that's a 7, over 1 times s squared, that's an s squared. As your s approaches positive infinity. Simplifying that one, limit of 1 as s approaches infinity, that is still 1 over the limit. The limit here, you can actually get that inside the radical symbol. So limit of s squared over s squared, that's 1. So limit of 1 as your s approaches positive infinity minus the limit of 7 over s squared as your s approaches positive infinity. So simplifying that one, we have 1 over square root of limit of 1 as your s approaches positive infinity. That's a limit of a constant, so we have 1 minus the limit of 7 over s squared. we can take out the 7 here and then multiply that one with the result. But you can actually do the shortcut of that one, because once you take out 7, we are left with 1 over s squared. That's giving off a 0 once we evaluate the limit. So automatically 7 times 0 is a 0. So 1 minus 0 is 1. So we have this as 1 over 1. So that will be equivalent to a 1 as our limit for this particular expression. Lastly, we've got the limit of the square root of 4 plus 3r minus 2r squared over 4r as your r approaches negative infinity. So we will be now multiplying this one with highest exponent here on the top is r squared. But take note, we are going to base our expression to be multiplied at the top and at the bottom part based on the denominator. Highest exponent on the denominator is 1. So all we have to do is to have it as 1 over r. Now, instead of 1 over r, multiplying 1 over r at the top, we cannot do that one because we cannot let that in the radical symbol, because we don't have radical symbol for 1 over r. So we do the same thing. We have 1 over r. We are going to look for a corresponding value wherein we've got the radical symbol. But once we simplify that one, that will still be 1 over r. So what we're going to do is to simply square these things, the numerator and denominator, and that will be the one inside. Okay, so let's try to do that one. So 1 squared is 1. Over r squared is r squared. So if you try to simplify this one, we have square root of 1 is 1, square root of r squared is r. So they are equivalent. So what we're going to write here is square root of 1 over r squared. And then we are to simplify this one here. So we have now the limit of the square root of 4. We can actually distribute that one right away. You can skip on the process. So we have 4 times 1 over r squared plus 3r times 1 over r squared, and then minus 2r squared times 1 over r squared. And then at the bottom part, we have 4r times 1r. 4r times 1, that's 4r. Over our r times 1 on the denominator of 4r, that's an r. As your r approaches negative infinity. Simplifying this one, this is now with a limit of the square root of 4 times 1, that's 4 over r squared, and then plus 3r times 1, that's 3r, and then r squared here, minus 2r squared at the top, and then over r squared. All over, your r will be canceled here, so this is now 4. And then as your r approaches negative infinity, simplifying this one further, we can put the limit inside the radical symbol. So we're now skipping things here so that it will be quicker. So we can put the limit inside here. So limit of 4 over r squared as your r approaches negative infinity, plus your r here can be canceled. And then we've got, if we cancel 1r here, because once you say r squared, that's actually equivalent to r times r. Now we have 3r here over r squared, which is r times r. We're canceling 1r here. So we are left with a 3r. 3r. And again, we still have a limit for that one. So if we are to write it again, this is now with limit of 3 over r as your r approaches negative infinity. And then we have minus r squared will be canceled. So minus the limit of 2 as your r approaches negative infinity. All over, we are to put a limit at the bottom part as well. So limit of 4 as your r approaches negative infinity. So simplifying this one, so we are now going to simplify that. So we have the square root of limit of 4 over r squared, we can take out 4. We are left with 1 over r squared here, which is equivalent to a 0 once we evaluate the limit. 0 times 4, that's a 0, plus your 3 over r, that would lead to a 0 as well, because once you take out 3, what is left here is 1 over r. 1 over r, limit of that is 0. And then we multiply that with 3, that is still a 0. And then minus, we've got limit of 2, that is a 2. Over, we have limit of 4 as r approaches negative infinity, that's a 4 because that's a limit of a constant. And then we have square root of negative 2 over 4. Square root of negative 2 is imaginary number, so that means to say that our limit here does not exist. So that is how you are going to evaluate your limit once your limit is at infinity. So I hope you learned something. And please practice more so that you will be able to master the concept of this.